Hey all, lesson 3.7, solving ax plus b is less than c. This is just the generic format. We will be solving all sorts of inequalities today. The learning target would be that students can use properties of inequalities to solve an inequality. This is a review. In our last lesson, we talked about properties of multiplication involving inequalities. We knew that we can multiply or divide both sides of an inequality by the same number. If that number that we are multiplying or dividing by is a positive, it will maintain the sense of the inequality. However, if it is a negative, then it will flip the inequality over. What happens if we were to add to both sides? Considering the idea of positives and negatives, adding 8 to both sides of an inequality appears to maintain the sense of the inequality. Adding -5 to both sides of an inequality also appears to maintain the sense of the inequality. Same thing with 1, same thing with 10. It doesn't seem to matter what value we add to the inequality holds to be true. If we take a look, not only does it maintain the sense of the inequality, but it maintains the same solution set. That is, in fact, the addition property of inequality. Adding to both sides of an inequality maintains the sense and solution set of the inequality. Therefore, for all real numbers a, b, and c, if a is less than b, then a plus c is also less than b plus c. Adding the same thing to both sides of the inequality will maintain the solution set and the sense of the inequality. We use this property to, of course, solve inequalities. They're solved mostly in the same way as an equation. We use our reverse PEMDAS. We undo the addition, the constant term first, and then we move into undoing the coefficient, the multiplication. We always want to be mindful of the sense if we multiply or divide an inequality, remembering that if it is multiplied or divided by a negative number, we do need to change the sense of the inequality or flip the inequality symbol. Our first example, solve and check, graphing the solution set to the inequality on a number line. Here, the inequality that we are asked to solve, 6 is less than or equal to -4b minus 10. We would solve this much in the same way that we would solve if it said 6 is equal to. We've got our left side and our right side. First thing that we would consider is to undo the addition, add the opposite of the constant to both sides. Here we would be adding 10 to both sides since our constant term was a -10. Minus 10 would indicate a -10. We simplify by combining any like terms, showing us 16 is less than or equal to -4b. At this point, we've got just a multiplication inequality. Therefore, we have a coefficient that we need to remove. So we will undo the multiplication by dividing by the coefficient. Do we need to change the sense? This time, yes, the sense does need to change because we are dividing both sides by a -4. Simplifying the common factors, I see that -4 is greater than or equal to b. We want to check the boundary and the sense. Remember to check the boundary, we check for equality. If I substitute this value that we found into the original equation, or excuse me, the original inequality, I should see an equality. It should make the left and right side equal. So let's check that out. -4 is substituted. Order of operations becomes 16 minus 10, becomes 6. Here, our boundary does make the original inequality an equation, so that's good. We want to check the sense of the inequality. I'm going to use b is equal to -10. Just a little bit of a typo here. B is equal to -10 since -4 is greater than or equal to -10. Substituting in a -10 for that b value, following order of operations, it results in 40 is minus 10, or 30. And if I take a look, the original inequality is less than or equal to, and the final inequality is also less than or equal to. Again, another one. We're going to solve this mostly in the same way that we would an equation. We just want to make sure that we're very careful about the sense of the inequality if we multiply or divide by a negative. So let's check out another one, another one, not the same one that we already saw. Here we have a little bit more of a complex inequality simply because the expression on the right side of the inequality is a little bit more intensified. The first thing that we might want to do is try to simplify that before we begin. And we can do that pretty quickly by doing the distributive property, distributing that -7 times. From here, it still looks a little bit more crazy than what we've been experiencing, but there are some like terms that go together, so we can go ahead and combine our like terms. 5r and -7r combine to make -2r. From here, it's pretty straightforward as before. We want to undo our addition first. Add the opposite of the constant to both sides. Simplify our like terms again. We come up with 10 is greater than -2r. From here, we want to undo multiplication by dividing by the coefficient. Again, we're in an inequality, so we always want to be careful if there is a sense change. Since we are dividing by a -2, you'll notice that we do need to change the sense of the inequality. Simplifying our common factors, we find out that -5 is less than r. Check our boundary point. It should make the original inequality actually an equation equal on both sides. So testing it out, following our order of operations, says that 3 equals 3, so that means that our value of -5 is correct. We always want to check the sense of the inequality. I'm going to try a 0 for r, since -5 is less than 0. If I test out a 0 in the original inequality greater than holds true. 3 is greater than -7. So that checks out too. We can see this in some real-world word problem examples. Take a moment. Suppose a gas station charges $8 for a car wash, but you get $1 off if you buy gas too. If gas is $3.59 per gallon, how many gallons of gas could you possibly get if you wanted to get your car washed and spend $30 at the most? So if we take a look, we want to spend $30 at the most. So we need to define the variable here. Let's let G stand for the number of gallons of gas that we would buy. Now we need to set up and solve an inequality. The cost of the gas should be less than or equal to $30. I want to spend $30 at most. Therefore, my $7 car wash plus $3.59 per gallon is less than or equal to 30. Go ahead and solve it out. Undo addition by adding the opposite of the constant. Simplify your like terms. 359g is less than or equal to 23. Undo multiplication by dividing by the coefficient. Beware, there may be a sense change. You'll notice we do not need to change the sense of this inequality because we are dividing by a positive value. Simplify our common factors. G is less than or equal to 6.4067, meaning the number of gallons of gas that we would want to get would be less than or equal to about 6.4 gallons.